Okay, so ratio strength is another way to express the strength of a medication. Usually you see ratio strengths when there is a very little amount of active ingredient in a drug. Now at the top of your math worksheet, at the very front, I wrote ratio strength here on the left side. So really make sure that you don't confuse ratio strength with percentage strength, okay? So we are still comparing the amount of active ingredient to the total volume or weight in a product. However, this time we are going to be using 1 2x or 1 over x in this case. And now this time our 1 is our active ingredient and our x is going to be the total weight or volume. Now just with any type of drug, you can either have a weight per volume, a volume per volume, or a weight per weight. So we're still using the units of grams and milliliters. So if your problem gives you something in milligrams or something in liters, you're going to have to convert those first before you plug them into your equation, or you will not come out with the right strength, okay? So let's take a look here at some examples. So once again, ratio strength is always 1 to x, or in this case, if you write it as a fraction, 1 over x. Now, very similar to percentage strength because we still have our active ingredient on the top. We still have our total volume on the bottom here, okay? But our x has switched places now. Remember, percentage strength, our x is our active. Ratio strength, our 1 is our active. And that's just because there's very little amount of active ingredient in the total volume or weight here. Now, x in ratio strength is not always going to be 100, so this will be different, okay? However, our units are the same. We're still using the same types of medication. So let's take a look at number 11 on the worksheet here. I think it's easiest to just start out here. Number 11 says, interpret the following. So we just need to interpret. We have a 1 to a 1500 sodium bicarbonate solution. Now they don't specify what type of drug, so we're always going to assume weight per volume when they don't specify. Now remember, our 1 in this case is always our active ingredient. So here we're just interpreting this. There would be 1 gram, because this is a weight, of sodium bicarbonate in every 1500 milliliters of solution. So all I did was just take my ratio and write it out in word form here. So there's 1 gram of sodium bicarbonate in 15,000 or 1500 milliliters of solution. So on practice problem C, when they're asking you to interpret the ratios, this is what I want you to do. Just write it out in words. Now, let's take a look at number 12. How many grams of sodium bicarbonate are in 650 mils of a 1 to 1500 sodium bicarb solution? So we still have the same solution here. So let's just take our ratio first and write it as a fraction. So we know that there's 1 gram of sodium bicarb in every 1500 mils of solution. Now we're going to set that equal to what we're looking for. It says how many grams of sodium bicarb. So I know my x is going to be on top, and I have 650 milliliters of solution. So now I can solve for x. So here I have 650 equals 1500x. Divide by 1500 on both sides. So here, let's see, we have 650 divided by 1500. That gives me 0.43. I'm just rounding to the nearest hundredth grams. So 0.43 grams of sodium bicarbonate. Now it says, what is the strength in milligrams per milliliter? Well, it doesn't matter which one we start out with because both of these fractions are equal to each other. So if I wanted to start with this one, we can do just that. So we have 1 gram in every 1500 mils. So we want to turn this into milligrams per mil. So 1 gram, if we convert that into milligrams, that would be 1,000 milligrams. This would stay the same because 1 gram is equal to 1,000 milligrams. Now I want to reduce this to milligrams per mil. So I can just take this and divide 1,000 divided by 1,500, or if it helps you, set this equal to x over 1 mil, because we're just solving for 1 mil. So it would be 1,000 divided by 1,500. So if you enter that in your calculator, x will give you 0.67. I'm just rounding to the nearest hundredth milligrams. So my strength would be 0.67 milligrams per every 1 milliliter. Okay, number 13. A physician orders 60 mils of a 1 to 250 sodium hypochlorite solution to be used in the office. How many grams of sodium hypochlorite are needed to prepare the solution? Well, let's start with what we know. We have my ratio here. Doesn't specify what type of drug, so we're going to assume that it's a weight per volume. So 1 gram of my active ingredient, sodium hypochlorite, in every 250 mils of solution. Now they're ordering 60 mils and it's asking for how many grams. So I know that my X has to go on top for grams and I have 60 mils here on the bottom. So 1 times 60 is 60, and then we're going to take that divided by 250. So X here would give us 0.24 grams. Now it says, how many mils of solvent are needed? So let's think back, if we're telling somebody to make this compound, what are they going to have to do? Well, we just solved for how many grams of powder we need. We need 0.24 grams of sodium hypochlorite, and we know that we want to make a total of 60 mils. But remember, if I just have this powder, if I just added this powder into my container, that's going to take up space of its own. And we need to get up to a total of 60 milliliters. So I cannot determine how much solvent I actually will be adding into my container. So in that case where we cannot determine that, because this is in grams, my total is in mils, this is where we would use the QS. Okay, so we would say QS to our total volume, so QS to 60 mils with solvent. So if my active ingredient would have been in milliliters, if this would have been a volume per volume, well, then I could have just subtracted this out of my 60 mils. That would have gave me the difference so I could actually solve for how much solvent. But because this is a dry ingredient, it's a weight, I can't just simply convert that into volume. So that's why we have to use the QS example here. If you're still struggling with this concept to understand that, please come and see me and let me know, and I'll be more than happy to show you that physically as well. So now I would like you to do number 14 on your own. So remember, start with your ratio. This is a 1 to 1,000. We're going to assume it's a weight per volume because they don't specify. So you're solving for how many mils of epinephrine solution. So you're solving for mils. Are needed to provide a 1.5 milligram IM dose. So remember, the units for weight that we'll be using in our fraction here will be in grams on top. So you're going to need to convert this to grams first before you plug that into your equation. Okay, number 15 says, what ratio strength solution is made by dissolving Benadryl 25 milligrams in a lotion to make 120 mils. So now this time they give us our active ingredient, they give us our total volume, but they're asking us for the ratio strength. So this time we're going to have to figure out what our ratio strength is. So let's start with what we do know. We do know that we have 25 milligrams of Benadryl in every 120 mils of our lotion. Now we're solving for what is the ratio strength. Now remember, ratio strength is always 1 to x or 1 over x. So what we can do is set this equal to 1 over x. But do not forget, when we're doing a weight per volume, remember our units of weight are always in grams. Now here, our units are in milligrams. So we're going to need to either convert this into grams or convert this 1 gram here into milligrams. I think it would be easier to just go ahead and convert this into milligrams. So if you do 1 gram, you should know by now, 1 gram is equal to 1,000 milligrams. So if we just change that to 1,000 milligrams, now I can solve. So here we have 1,000 times 120. Let me get my calculator here. So 1,000 times 120, that's going to give me 120,000. Actually, I apologize. So we're going to actually need to leave this in grams because it's asking us for the ratio strength. It's not asking us for how much solution is going to be made from 1 gram of active ingredient. So we're actually going to need to convert this here instead. Okay, so since we know that this has to be in grams, we're going to need to convert our milligrams here into grams. So when we're going from milligrams to grams, our decimal would be behind the whole number here. So we're going to go 3 places to the left. So this would become 0.025 grams. So I'm going to cross that out and just replace that. All we did was convert our milligrams into grams. Now we can solve for our x here. So we're going to have 120 equals 0.025x. Divide on both sides. So 120 divided by 0.025 leaves me with 4,800. Okay, so that would be 1 over 4,800. We're looking for the ratio strength. always leave it in a ratio form. So it would be 1 to 4,800 here. Okay, now looking at number 16. What is the percentage strength of a 1 to 13,500 weight to volume solution? So we're looking to go from a ratio into a percentage strength. So first, let's start with what we know. We have a weight to volume, we have a 1, so that must be grams because that's weight, and 13,500 milliliters because that is in volume. Now we're looking for percentage strength. So let's look back. Remember, percentage strength is always X over 100. So all we would need to do here is set this fraction equal to X over 100. So here we have 100 divided by 13,500. So that leaves me with 0.007. I'm just going to leave that here. Just round to the nearest thousandth here. It does keep continuing, but that's enough to the significant digit there. Now remember, the X in our percent strength fraction, that is our percentage, okay? So this would just be 0.007%. A lot of people get in the bad habit of trying to move your decimal after this calculation. You don't need to because that X is our percentage. And you can see that your percentage strength is going to be really small the larger the second number of your ratio strength gets. Okay, so go ahead and solve for number 17 on your own. Just keep in mind this is a weight to weight ointment, so that would be grams per grams, but we're still looking for percentage strength. So remember, percentage strength is always X over 100. So pause the video, solve for number 17 now. Okay, now number 18, we're going the other way. It says, what is the ratio strength of a 0.025% weight to volume solution? So here we have a percentage strength. Remember, anytime you see a percent, just take this number and put it over 100. So 0.025 over 100. This is a weight per volume, so it's going to be grams per mils. Now this time we're looking for ratio strength. So remember, ratio strength is always 1 to X or 1 over X. So in this case, we're just going to set this equal to 1 over X. That's going to solve for the second part of our ratio. So here I'm taking 100 times 1, it's just 100, and we're dividing that by 0.025, which here gives me 4,000. Now that's my second part of my ratio. Remember, ratio strength, leave your answer in a ratio form. So this would be 1 over 4,000 or 1 to 4,000. Now, with that example, you should be able to solve for number 19 and number 20 as well. So now after this lecture, you should be able to work through practice problems C, D, and E on your own. If you're struggling with any of these concepts, feel free. After the comp lecture on Monday, I will have an open Zoom time to ask me any questions that you're struggling with on these concepts. So please stick around and do that. If you haven't got to watch the lecture before then, if you're going to watch it on Monday, then plan on coming in on your work day if you still have questions. or stop by and ask me any questions that you have on your lab day as well.